If you're running modern distributed systems, your logs already live in object storage that acts as a durable layer. It's cheap, scalable, and reliable. However, the problem isn't storing logs. The problem is searching them efficiently, without standing up heavyweight clusters or duplicating data into another system. In most architectures today, you have two choices. You either ship logs into a search cluster and manage cluster sizing, contention, and cost, or you leave them in object storage and rely on batch analytics or ETL to make them queryable. At scale, both approaches create friction. Clusters need constant right-sizing. Ingest and query compete for resources. You provision for peak and pay for idle. That's not a data problem. It's an architectural one. Mach 5 takes a fundamentally different approach. First, storage and compute are fully decoupled. All index data lives directly in object storage. Ingest compute and query compute are completely independent. However, in traditional cluster-based systems, ingestion and querying share the same infrastructure. If ingestion spikes, query latency suffers. If query demand rises, you scale the entire cluster. In Mach 5, ingest runs on its own compute plane. Query runs on independent warehouses. Storage is separate from both. As you can see, Mach 5 works on a multi-warehouse architecture. If a complex investigation requires heavy compute, you spin up a larger query warehouse. When queries stop, you shut it down. You do not provision for the worst-case combination. You provision for actual workload. Let's see some search-heavy examples that you can perform with Mach 5. We have enriched IP traffic logs stored in Amazon S3. These logs could come from firewalls, load balancers, CDNs, or authentication systems. To begin working with your data in Mach 5, the first step is to establish a connection to your S3 bucket. We create this connection because Mach 5 doesn't replicate your data into some separate store. It reads directly from the source of truth. Your logs already live in S3 because it's durable, scalable, and cost-efficient. Mach 5 builds on that strength instead of duplicating it. Once that connection is configured, we define an ingest pipeline. An ingest pipeline tells Mach 5 how to read and normalize your raw files, like line-based logs, JSON blobs, or compact structured records. This pipeline handles schema inference, data transformation, field extraction, and any enrichment logic you need. The goal isn't to move your data, it's to make the data searchable while it stays in object storage. After the pipeline is in place and data begins flowing through it, the next step is to create an index. Mach 5 writes search-optimized structures on top of the object storage dataset. Once the index is built, the data is ready for low-latency search. Let us look at some search-based use cases that can be performed either using Elastic DSL and MQL in Mach 5. From a SOAP perspective, the first question is simple. Where is traffic coming from? We run a parallel search query in DSL and MQL that aggregates by country. This is not a full table scan, it is an index-backed search over object storage. Once we run the query, we immediately see geographic distribution patterns in the log dataset. Now let's move to a more advanced behavioral detection, query of impossible travel. We want to detect users appearing in different countries within hours on the same day. To do this, we ingest a second dataset containing login activity and create another ingest pipeline. We now have two independent index datasets, one in network context and the other showing user activity. Both are searchable on their own. In many systems, correlating these would require pre-joining data, duplicating it, or maintaining enrichment pipelines. Here, we join at query time using IP as the key. When we run an impossible travel query for user 001, we immediately see logins from the US, Turkey, and Poland within hours, which is clearly anomalous. For SOC teams, having joined directly on search means faster investigations, no pipeline delays, no separate analytics layer. Let's look at another common problem in operational search, handling imperfect data. Instead of requiring exact matches, Mach 5 supports fuzzy search, which allows queries to match terms that are similar, not just identical. Log datasets often contain spelling variations or typos. For example, an ISB might have other misspellings depending on the source system, like Apple might appear in logs as Apple with single P or triple Ps. Here we search for Apple as an ISB using fuzzy matching. Even when the spelling varies slightly in the dataset, the search still returns the relevant records as seen in the results. For security teams, this is important because investigations rarely happen with perfectly formatted data. Fuzzy search ensures analysts can still locate the right events quickly. Everything we demonstrated, filtering, fuzzy search, and cross-dataset correlation, runs directly on data stored in object storage. In Mach 5, storage, ingestion, and querying are independent layers. Ingest compute scales with incoming data, while query warehouses scale with investigative workload. The result is fast search on object storage without cluster contention or over-provisioned infrastructure. If you'd like to explore this architecture in more detail, you can request a demo at www.mach5.io.